Our intuition was, okay, so some sort of parallelization should happen with those kind of sharding, and proof of stake was intuitively the design that we should approach. And everybody said, no, it's not doable. If we take the blockchain trilemma from Vitalik, that you cannot achieve scalability, security, and decentralization without compromising any of those without sharding. I always envisioned that Ethereum would eventually define a standard where all those headers or data that is being pushed into the blocks, into the Ethereum beacon chain, will kind of get synchronized across the L2s. You kind of build some sort of a trustless finality model synchronized across all the L2s. If you would apply the same Elrond or MultiversX model to the Ethereum case. The only problem is...
Welcome to Epicenter, the show which talks about the technologies, projects, and people driving decentralization and the blockchain revolution. I'm Felix Lutsch, and today I'm speaking with Lucian, who is the co-founder and CIO at MultiversX. MultiversX, previously known as Elrond, is a fully sharded blockchain network and ecosystem. Before we talk with Lucian, we'd like to tell you about our sponsors this week.
This episode is proudly brought to you by Gnosis, a visionary collective committed to fostering and expanding applications for a decentralized future. Gnosis is at the forefront of innovation with Gnosis Pay, Circles, and Metri, revolutionizing open banking and creating a superior form of money. With Hashi and Gnosis VPN, they are building a more resilient and privacy-focused open internet. Are you seeking a robust L1 to launch your project? Well, look no further than Gnosis Chain. Enjoy the same development environment as Ethereum, but with significantly lower transaction fees. And with a robust network of over 200,000 validators, Gnosis Chain stands as a credibly neutral and resilient foundation for your application. Governance at Gnosis is driven by Gnosis DAO, where everyone has a voice in shaping the project's future. Join the Gnosis community today by participating in the Gnosis DAO Governance Forum. You can deploy your project on the EVM-compatible and highly decentralized Gnosis Chain, or help secure the network by running a validator with just a single GNO and low-cost hardware. Embark on your journey towards decentralization today at gnosis.io.
Chorus One is one of the biggest node operators globally and help you stake your tokens on 45 plus networks like Ethereum, Cosmos, Celestia, and DYDX. More than 100,000 delegators stake with Chorus One, including institutions like BitGo and Ledger. Staking with Chorus One not only gets you the highest yields, but also the most robust security practices and infrastructure that are usually exclusive for institutions. You can stake directly to Chorus One's public node from your wallet, set up a white label node, or use the recently launched product, Opus, to stake up to 8,000 ETH in a single transaction. You can even offer high-yield staking to your own customers using their API. Your assets always remain in your custody, so you can have complete peace of mind. Start staking today at chorus.one.
Hi, Lucian. Welcome to Epicenter.
Hey, Felix. Pleasure to be here.
Awesome. Yeah. So glad to have you. I think, you've been in the space for a long time with Elrond previously, now MultiversX. I think there's like a lot of stories you can tell about proof of stake, about what you've been building. And so, we wanted to basically just start there. Like, how did you get into crypto and started building like Elrond and now, I guess, MultiversX?
Definitely. So first thing first, thanks a lot for the invite. Thanks for hosting me, Felix. By the way, big congrats and respect for the entire Epicenter team. I think Epicenter is perhaps the podcast where I learned most of the crypto stuff in my entire life, like in the entire career. So I've been following ever since I met Sunny in 2017. Just to give a brief context, how I discovered first Epicenter, then we'll move to my background. But actually, I met Sunny in Zug into one of the very early crypto conferences. He was presenting Cosmos ecosystem, and it was prior to mainnet. I think it took one and a half years after, if I remember, after Sunny mentioned. It will follow very shortly. Cosmos launch will be very shortly, and immediately, actually, I fall in love with a lot of the stuff that you guys were presenting, and more than happy, as I said. Big congrats, and maybe the second point is I have not, just to upfront disclosure, I have not did any podcast in the last 7 years since I built or started Elrond. And then the main reason actually why I'm here is after listening to one of the latest podcasts from Epicenter with Paulo Arduino, where he mentioned we all as technical founders thought, okay, we are gonna build such good products that the products will speak for themselves. And then that was my life thesis, that if everything went for 7 years, 6 years, and only with Elrond not going out, then basically once I heard his story and how important it is to go out, I decided I'll reach out, and here I am. So just a short intro, big respect for the entire Epicenter team.
Awesome. Yeah, thanks so much. That's such a great anecdote. I think, and we're super glad to have you and honored to be chosen as the first. I think your project obviously is technically like one of the very advanced sort of blockchain infrastructure. So it is only fitting that you come on Epicenter to dive into it. But yeah, I guess, let's start there. How did it start, or when did you sort of come up with the idea of like Elrond back then and now Multiverse, and how has it changed, if at all, or what was like the goal behind it?
Definitely. So it's some context. I think Benjamin, my brother, was the hook for me into the Web3 ecosystem. I've been building and have technical background, have built several startups in Germany, has lived the last 10, 12 years in Germany there, building all kinds of infrastructure projects for the German states, for startups, for large scale enterprises and so forth, and was very passionate about very simple logic of every protocol standard, like from TCP, UDP, and all that kind of stuff, going to BitTorrent and that kind of direction. So I think for me it was very, very important to try to connect to something that I could relate and understood very simple, but I could draw it like the protocol design on the whiteboard, right? So once you take like that and you just remove, for example, from BitTorrent, the seeder part, you immediately see, that's the Bitcoin, pretty much topology of the network. So basically it clicked. And then my brother tried to, he was already involved in, I think, NEM, one of the core team members at NEM, and I think on the Bitcoin Talk forum and so forth. Very, very, very all days. And then every time he had all this kind of task or challenges to solve, he flew to Germany over the weekend, hooked me again. We stood like one weekend first, and then more weekends and so forth, until actually we got the task needed for other protocols. And then after a while, he convinced me to move full time into Web3. We also had a fund back then where we actually ended up investing in Cosmos as well. I think in the private, in Polkadot, Zilliqa, pretty much everything what was infrastructure. Back then we were one of the first backers. And while researching pretty much all those new protocols, and working with them, trying to contribute to their ecosystem, actually we learned a lot of the stuff. And that was maybe the also one of the triggers where back in the days we look at the performance or capabilities of the throughput of all those protocols that were coming up from 2016, 2017, and so forth. And we just had the thought experiment, okay, well, if we're going to put like 8 billion people into any of these kind of architectures, would it stand? Would it still stay alive? Would it still we still reach consensus or have any kind of meaningful performance such that it could gain world adoption? And basically, we kind of reached the conclusion that the state problem or the state size of any of those blockchains will become pretty much the main killer of, and killer not as we use in Web3, the good part of killer actually literally will kill any kind of performance that could those architecture reach. And maybe well, the funny thing is that our intuition was, okay, so some sort of parallelization should happen with those kind of sharding, and proof of stake was intuitively the next the design that we should approach. And we went actually to several of those ecosystem projects that were already working on very complex problems, and pitched them that they should do sharding. And everybody said, no, it's not doable. So it's funny enough that everybody said, no, you cannot do that. It's too hard, too complicated. Why would you do that? And here we are, I think, after 6 years, 7 years with everything live, and Ethereum still, I think, arguing that some of the stuff are literally hardcore. I cannot not agree with that. There were many sleepless nights and many attempts to build this kind of stuff. But yeah, I think this is very briefly how also the background, and also how we got to at least have the thoughts in the direction of Elrond architecture, initial architecture.
Yeah, that's super interesting. I think, I guess there was a phase where the Ethereum scaling roadmap was also sharding based, and then it sort of shifted back to this roll-up architecture now, and we're basically still there, right? And I think in the wider space, some people depends on which pocket you are in. You maybe even forgot about sharding, that it existed. But then on the other hand, we have projects like you, and maybe I guess the other mentionable one is Near, that has implemented sharding actually. So super curious to hear from you more about how that actually works, and how you set it up to. And basically the problems that it solves. So maybe we can dive a little bit deeper in there, how you actually do the sharding. So maybe we start just from sort of the validator set that you have, and how they are sort of set up.
More than happy. So maybe just some context. Funny enough that you mentioned the sharding part, or the sharding from Ethereum roadmap. We actually worked with Prismatic Labs in 2017 on the Ethereum sharding model. So I just had a discussion on I think last conferences with explaining again how the architecture of MultiversX or Elrond looked like in the production. It was very similar to what Ethereum 2.0 looked like, especially at least the staking part with Q, with all those modules. Actually, Elrond and MultiversX had both of them actually brought to the production. But also another funny part, I would say, Sunny was, I guess, one of the first guys that did a peer review of the paper in 2017. And then also Vasily from Lido has been grilling me about the randomness source of the chain in 2016, 17, I think, or 18, something like that, around that, a lot, and eventually contributed to the architecture as well. So very nice actually to see that all those builders have contributed and always contribute. If there's something that builders have in common, they all contribute to the best things. Now, going back to the architecture model of MultiversX and going a bit into the technical stuff, I would say the first step would be to walk the thought process that I look at as at any blockchain architecture pretty much. So if we take, for example, Ethereum as a supercomputer is still a computer in the end, and it has three major components. So you have kind of CPU, RAM, disk, where CPU is consensus. You throw a lot of requests at it. It works with a very fast memory, which is the RAM, where you basically iterate or permutate those values once you reach consensus, and you write to the disk how you got there, right? So this is like, I would say, blockchain 101 explained in 30 seconds. And also as a supercomputer, distributed over the internet, and then that's kind of it. But the next point would be, if we look at general compute architecture, how we scaled up the system, we did not end up with a CPU with a single thread that has 100 gigahertz, but rather we have a bunch of threads that parallelize the execution. They all of those threads work with a very fast memory, which is the RAM, where you have, even though you have physically the RAM as one piece, actually each of the threads are having a pre-allocated subset of memory, right? Which is like each of the threads, in order to work, in order to be able to process it, actually reserves a set of memory of the RAM. And then, of course, once they reach solve the data, the request, it writes to the disk how we got there. Now, this is like the general compute. This is also, if we look at Elrond or MultiversX, how it looks like or how it works. Actually, you have the beacon chain similar to Ethereum 2.0, and then you have a bunch of execution shards. If you remember the initial Ethereum sharding architecture, it basically push out the state to the execution shards, where the state transition will be maintained on the execution shards. So basically you have this kind of beacon chain, which is notarizing all those blocks being produced on the sub shards or the execution shards level, while basically that allows and goes us basically to the entire sharding model. Maybe before going even more into specific and losing pretty much maybe a bunch of the guys what is being notarized, what headers and so forth, I would just do a step back, maybe defining a bit the problem of the sharding, right? I would say one of the points here so like there are three kinds of sharding. So there's I would say transaction sharding, where we have had architecture similar to Zilliqa. Zilliqa, for example, was one of the first one that proposed that kind of model, which allowed any kind of state transition or kind of move balance parallelization within the same chain, within the same binary, right? So that's cool. However, as soon the chain has hit one transaction or one smart contract transaction, for example, which would have iterated multiple counts, there would have been a memory lock on the entire state, and that would not allow any kind of parallelization at this point. So the next point would be there's like the network sharding. Like if we look and, for example, the way the architecture is being built on our case, we have a total of 300 to 3,200 validator seats, and all those seats are being allocated into 4 chunks or 4 sub shards. Each of them maintaining 800. In this case, like Beacon Chain has 800 validators, Shard 0 has 800, Shard 1 and 2, each 800. Basically, at the network topology level, there's on top of peer-to-peer an authentication layer where it tells, like, once you go, and again, this might be a bit technical for people. Basically, once you go into and you connect to the peer-to-peer network, you need to have some sort of an ID, like a public-private key infrastructure. Now, on top of that, what you can do, actually, you can sign the messages with the private key of the validator, which will tell the other counterparty, which is receiving the message, if what kind of peer are you? So are you coming from the same shard? Are you coming from a different shard? And basically, there's a specific optimizer set which will tell each of the validators, hey, I have a maximum, for example, like, again, just defining the problem, like network traffic is perhaps the most expensive resource we have in the internet right now. And that's one of the problems also that we need to optimize. So assuming that you can have into a parallelization system where each of the validators maintains only a subset of the network, you also need to pass a lot of those messages and kind of find the optimum route to connect those peers to each other. Now, because of this kind of first, you have, as I said, the authentication method or the signing method with the validator key on top of each of the messages. Then on the other side, assuming that I'm synchronized and I'm synchronized with the network, I can tell the public key that has signed this message where it comes from. Based on my knowledge of the network configuration, I can tell, okay, this public key should be actually validating, or should be a validator in shard 2 or in the meta chain. And I can assign this public key or this network connection to a routing protocol where I keep a certain amount of connections optimal or for an optimal broadcasting method or propagation protocol in order to reach and always have highly available high connectivity and low latency between validators intra-shard, and still maintain some sort of a cross-chain connectivity for with all other shards, such that they will never become a lonely island. So there's I hope, let's break here and maybe I let you ask some questions. I know there's a lot of stuff, there's very specific layers, but more than happy to explain everything.
No, sounds great. That's super interesting. So basically, first of all, maybe one question: the meta chain, which is like kind of the beacon chain, I guess, in your system, it's not that every validator actually validates that as well. So, but rather it's also like just a normal shard in some sense.
No. So basically, there's first there's shared security model. So basically, the entire pool of 3,200 validator seats are randomly allocated around among all the shards. So there's no special configuration, no special preferences for the beacon chain. You just basically get every epoch shuffled and being allocated to that shard. The only difference is in the current configuration is that the consensus size or the consensus participation for every round is 400 or 400. Like I could maybe just define a couple more stuff. let's do, right? So basically there's if we go on the chronology part first, right? So let's define what's the metric of accounting or measuring inside the blockchain. So we have epochs, which are equal to 24 hours, and then there's rounds. Current round time is equal to 6 seconds. Which will get improved with the next protocol updates to, I think, 3, 2 seconds, 1 second, and hopefully sub-second finality before the end of the year. Maybe now that's chronology. Then there's validators, which have two different states or had two different states. So there's active and waiting. The reason for that is basically each epoch, 400 validators are being elected to validate each of the shards, including beacon chain, where so 400 are being elected and the other 400 are in the waiting state. Why? Because there is every epoch the validators are a third of the validators are being random sampled to reshuffle across the shards, such that they will never be able to collude to take over a shard. So by doing that, basically, we also have a built-in protocol time for those validators to synchronize the new state. So assuming, for example, that I'm being relocated to a new shard, then I have a built-in in the protocol a guaranteed time frame for my node. Even if I will just, like, in practice, the node will destroy and delete the entire database, will just go and synchronize the snapshot, the tree snapshot from the current epoch, and then build on top of that the current state of the chain, assuming that at the next epoch change, I am eligible to become validator, right? So maybe that's very raw a bit how the consensus or chronology works, and then also a bit tied to the shuffling part.
Right. Yeah, that's super interesting. And this syncing, like, how long does it actually take right now? Or because I guess you need to be able to do it in 24 hours, but it.
So there are two parts. There's basically first there's 3 snapshots. So we like tree pruning. We implemented the tree pruning, which allows us actually at each of the epoch change to clean up the old state. Like the tree will always maintain only the latest and greatest, so to say, version of the leaves or the tree model, which will be actually transferred in the new snapshot, where basically that gets to the next problem, to the state sharding, because maybe define, like, right now it takes just to answer your question, it takes, I think, around maybe hour, 2 hours, and that could be optimized, and we have optimized a lot and so forth. However, this is like the general problem, what we're doing. And now, so we kind of touch on the network sharding, we kind of touch about the design and rationale, why you need, like, putting network sharding on top of this kind of architecture. You kind of see all this kind of engineering breakthroughs on top of all those primitives to highly optimize the throughput of the network and the latency. However, the main problem, I think, what we were solving is the state problem. And, like, if you take the state or if you take like put the world population of 8 billion people into just a database and try to iterate and do hundreds of thousands of transactions or thousands of transactions per second while finding those accounts, like you need to iterate on 8 billion entries inside that database, find those entries and change the values and then redo the search for the next one and so forth. So that could not scale. And also in the same time, try to replicate this database as many times across the globe. Like if we take the blockchain trilemma from Vitalik, I think that's the most famous one that everybody knows. You cannot, like the problem says that you cannot achieve scalability, security, and decentralization without compromising any of those without sharding. Like sharding is was the design for that. And actually what it does, if, for example, if we take the Ethereum address range as an example, and you would take 0x000001 as a beginning, and then you have 010 at the end as an end, and you would split into a sharded model, those each of the shards will persist only a subset of those accounts, right? So in practice, the storage, like everything related to those accounts will be pre-allocated or allocated to a specific shard, and that specific shard will maintain the storage of it. While now, if we take and do a step back at the consensus or the entire architecture model, basically you can, if for example a transaction would be intra-shard, like assuming that the first 0 to 5 are in the same shard and the next 5 to 10 are in the next shard, basically each of the shards could process in parallel. They will run consensus every block, and then basically when the transaction is intra-shard inside the same storage, it will happen atomically, and then when not, then it will just reach out over the beacon chain through the notarization method. And that's, I think, the next point where we're gonna dive into. But I'm pausing here again, letting you maybe to ask some questions if it's clear enough, if it is.
Yeah. So you still always go through the main to the beacon chain, ask for like shard interoperability, and I guess, does it work? I remember from like Near actually that, if like some transaction is actually on the same shard, they still kind of wait this one epoch and delay it, so there's no benefit of being on the same shard somehow. Is that like something you guys do as well? Or?
Yeah. So there are two problems here. So the first is the composability problem. I guess that's the most interesting. I think the only reason why Ethereum have not implemented sharding yet, right? So like assuming that you run consensus on each of the shards, and for example there are 2 shards and the beacon chain, every time a transaction needs to, like, it is assuming that I have the account with the ID, like with the ending 1, and then I'm calling a smart contract which has it is in the same shard, and basically everything happens atomically. In the same transaction, I can just compose and so forth. However, if for example the account that I'm trying to go to is outside my postal code, just to quote the Near podcast as well. Basically, I need to go through the router, right? And the router will kind of ensure me the guarantee of the message delivery. However, it will not happen at the same in the same block. But here there are two problems. I would say first, there's the throughput problem. Like you could still try to concentrate everything into a single blockchain. However, there are some sort of improvements that could be done in order, or like engineering steps that could reach to atomic composability across multiple shards. But the most interesting part, I would say that's the easy part. Almost, I would say once you have a sharded blockchain, it's easier to go back and compromise again. I would almost compromise again and then kind of reach consensus across all the shards, whereby the most crazy part is that nobody solved until now or before Elrond the full state sharded problem. Like the cool part is, for example, now let me break it down to something that I think is also very, very, very known for everybody. Like the travel agency problem, where I think it was described in Ethereum forums back then, where you want, for example, I'm an end user, and I go to a travel agency, and I want to, regardless where the accounts are being distributed inside this architecture, I want with the same ticket, I want in my offer, if I buy this holiday ticket, to get a train ticket, hotel, a car rental, and a plane. And if I buy into the smart contract, the results should contain all of them or nothing. Now, this is the cool part. Like, nobody says that everything even in computer science problems, not everything happens synchronously. Not like even the way we communicate right now is not synchronously. It has an asynchronous model which guarantees the transport of the messages, and then we build on top of those transfer messages a bunch of algorithms or a bunch of software which can handle this kind of the modular approach. And now, if we look like the way we approach, like what Multiverse or Elrond or Sharding promises, is it guarantees a way of forwarding messages from A to B, but with some specific properties. Like, for example, if you know that the message will take a while, you can basically go and lock that memory. You can define the interfaces, so to say, on top of that to work and specifically say, hey, I want for this ticket, for the smart contract that is going to purchase everything, I want them to await and store this kind of information, and asynchronously, like when I'm calling this contract, the contract will send a receipt or will send 10 other transactions that might take even 2 seconds, 5 seconds, or 2 blocks, 3 blocks, whatever. And whenever they will reach their destination, I'm awaiting a message back, and I know the protocol guarantees a message back to me, and it will tell me what to do, if it is successful or not, right? So this is like the beauty of asynchronous execution, that you can build primitives or on top of those primitives, and can build on top of this messaging layer where you can asynchronous call and have composability and also not compromising on the throughput of the network, right? So this is kind of it. And maybe the even crazier part is knowing, for example, the part with the network sharding that I've been mentioning before. And also that the network itself is kind of synchronized over all this kind of primitives, cryptographic primitives, and consensus state. Basically, you could, if I know that, for example, in advance, like one of the looking maybe few seconds into the future, how could such a protocol still achieve what everybody else has, but what the other ones could never achieve sharding, just like that. Basically, if I know which transaction or what transaction I need to talk or execute synchronously, and I know the destination of it, basically I could easily target those validator sets, or the protocol could talk to those validator sets and make them achieve consensus for atomicity for one specific upcoming round, where they will execute one specific transaction from A to Z across all the accounts inside the chain, right? But in the same time, you can still persist this kind of asynchronous model for everything else, where you don't need to guarantee everything in the same block. Like the same way the internet doesn't guarantee us that everything just counts, drops everything, and just process one single thread at a time. I hope it makes sense. I think it's
I think it makes sense. So you're saying that you can, like, so there is a way to guarantee this somehow, and then basically in that specific scenario, more or less the shards act like a single shard for this string of transactions, or whatever it is.
But also while not uniting the state. So the consent, I can still work in like the same way. If the model works in an asynchronous model already, basically we will just speed up the message passing from one to another, and we will still do consensus on that kind of messaging. But instead of doing it asynchronously, if there's enough economic incentives, for example, for that kind of processing, it can be prioritized, scheduled, and then reached and executed into one single transaction. That could be as well. I mean, it's just an pure engineering problem. It's not something that cannot be solved. Like if we have solved all and built all this kind of stuff, then I do believe that that's just a couple of sleepless nights, I would say.
Just it took a few years. Yeah. Okay, that's interesting. So, but right now, can you do this prioritization, or is it like, I guess it leads a bit into, what are like the prioritized transactions in general in blockchain is like sort of MEV related, like arbitrage or whatnot across, like, is this something you can already do on MultiversX?
I think it's clear a bit how the logic of the sharding. Then on top of that, what we're building, maybe it would be, each of the shards, by the way, has its own VM. So it has its own execution environment and so forth. And on top of that, basically, we built at some primitives, which is called time lock and promises. Like you can define at the interface of each of the smart contracts what kind of properties do you want. Like defining, you want TCP or UDP. Do you want, for example, do you want that if like when I'm shooting to this smart contract and this smart contract calls another 10 smart contracts, does the user want whatever it gets, or do you want to await all the results of all the smart contracts? And if that passes, basically I'm just confirming, sealing that the result, or I can go back to those contracts and say, hey, I don't want them, right? So you can define all those kind of specific properties on each of the interfaces, how you want to do that. What we don't have is the synchronous consensus among all the shards, where I can do that. We don't have right now because it was not a problem. It is kind of a challenge for us, because we only had blockchains that are single-threaded. Let me put it this way: we don't even have the mindset to think about applications that are multi-threaded. Like, what if I can design such applications that can, instead of having just one single thread, one single smart contracts, for example, for wrapping or unwrapping tokens, or whatever else you're thinking, where you can actually have this kind of primitives available in all subshards. And then I think that's kind of the challenge of also Ethereum with rollups, that you only have some primitives available at one specific layer, and then you need to broadcast them, reproduce them to all other layers. I also have some interesting notes on that end, actually. But I hope it answers your question to that end.
Yeah. That makes sense. And I guess, you mentioned also like every shard has their own VM. Is it all like the same VM basically?
So we have three kinds of so first, on top of the blockchain, on top of the blockchain accounts, we kind of built a routing system where you can have multiple VMs. The cool part is you ended the data field. For example, when you're calling a smart contract, you can define, there's a kind of a switch where you can say, hey, I want this transaction to be originated, or the account that I'm talking to, I want them to call the bytecode with a specific VM. So I can tell through this kind of switch what kind of VM I want to. It's a storage at the end of the day. If we decouple the execution from the storage, then basically I can just tell, hey, go to that specific storage, take that bytecode and map it into a specific VM. In our case, we have a WASM VM. We built on top of a WASMer. It's called a space VM. And then there's a framework on top of that, which abstracts the entire complexity of sharding, which is called Spacecraft SDK, right? So the cool part is basically that's one of the frameworks. Like, this is the most used for anything smart contract related. And then also on top of that, we also have Go or like a system VM where we used, for example, for staking primitives, like system-specific applications or logic where you need very, very efficient computation and very fast. That's kind of the reason why we do that. The funny part is actually because of the new SDK, like the sovereign chains, I think we'll again touch on that as well, is we're incentivizing people, and because of the entire modularity that we build on top, we're actually putting grants for people that would take and build port different VMs to the ecosystem. So, for example, there's one of the projects that I'm very excited about that does Ethereum EVM compatibility. So imagine that you basically, in the future, the main chain could, in one transaction, you're calling one specific smart contract, and then that specific contract, you could take the output and inject it into the next VM. That is, for example, you take a WASM bytecode, you're calling a WASM bytecode, and then you call a Solidity code, and then you take with that result, you reach composability across multiple VM, Move VM, Solana VM, and so forth, right? So that's kind of the end goal, the direction for the VM execution side. And then on the sharding part, there's a lot of consensus optimization. There's a lot of even the block time is, I think, from my point of view, a bit too slow. But 6 years ago it was reasonable, right? So
yeah, always something to do. Okay, super interesting. I guess especially like heading into the sovereign chains realm. I guess we have seen more and more this like application specific paradigm, I guess, play out, right? Like I think that's like where it started in Cosmos, and sort of like everyone built their own chain. Everything is a chain. Your fridge is a chain. And I guess Cosmos has this approach. Okay, you have the sovereign chains or like the app chains, and then IBC. In your case, that's like sort of the sharding, but now you're also bringing in, as I understand, like sort of a model to have your own chain within this system. Like how does it work? Is it also like, is it an additional shard? Is it just something that lives on a shard? Or how? Definitely. Explain a bit more what sovereign chains are.
More than happy. So maybe first, I would just define the problem. Like we've been very good on running multiple binaries, so like multiple chains in parallel, orchestrating them into an invisible layer. Would say orchestrating them through the beacon chain, such that you don't care where the accounts would leave actually in your entire architecture. And then by doing that, actually, we kind of learned and said, "Hey, we're kind of good on running this kind of specialized chains or almost parallelized chains. Why don't we just repack, rebuild the code base such that it will turn into an SDK, which actually could, if you look at the internet architecture, you don't have just public cloud where you're sharing the resources with everybody else. What if you could just deploy your own private cloud, but still maintain all your own sovereignty? Like the cool part is like, first, you get all the primitives, everything that we built with Elrond on MultiversX for the last couple of years out of the box, but also pretty modular when it comes to you can define your own consensus size. You can run your own consensus. You can, for example, decide at which point in time you want to post the transaction to another chain. Like you're not tied to MultiversX. You can basically decide, hey, I want to run a consensus of 400 or 400, for example, validators. I want to have POS. I want to have a block time of block time of 1 second. And I want every time there's an interaction, I can write into the Go binary. I can say every time there's an interaction with a specific address, you need to go and post this transaction to Ethereum or whatever. You can just compose this kind of new features on top of that. So that's kind of the narrative. I do believe, people, I think Sunny again was saying you're kind of copying the Cosmos stuff. But I mean, that's the beauty of it. I think from where it came from, people say, if you're being copied, it means that you were doing right? So definitely, I think Cosmos and IBC and so forth was the part where I learned most of the stuff prior to starting what I'm doing. Now, I think we defined a bit what the capabilities of the SDK. The narrative it is with it that it should go and serve other ecosystem better than what the main chain was designed to, And also with that, we're actually providing grants and supporting all this kind of new teams that are building this, like Polkadot had this concept of palettes, for example, where you can just build new modules that you can attach and compose. Like I think even Cosmwasm is a very, very good example that one team built something and then it got implemented to pretty much and provided a smart contract execution environment to all other platforms, right? I think first, besides the privacy or the sovereignty of your own application needs, you're also fueling a lot more innovation at the entire ecosystem level to connect and also bridge, have a bridging method to Solana, to Cosmos, to Ethereum and so forth. But not only on the virtual, like on the messaging part, but also where you can get and deploy the applications from there that have been built there into this kind of newer setting, right? So this is kind of an approach. There are three. Like I do believe, like one is the application specific logic. Of course, that's the best one. DYDX again is, I think, I love the podcast with the DYDX, by the way, here. And that's, I think, the best explanation what an app-specific logic would look like. Then there's the consumer grade, from my point of view, where you have this kind of gelato alt layer and all this kind of other application where you have consumer grade tons of blockchains that will be deployed. And then there's enterprises. And that would be, I think, another podcast to touch on what enterprises use cases would allow. But now, going again to something more technical, imagine that right now there's Ethereum as a beacon chain, as a meta chain compared to MultiversX, and then you have a bunch of shards, which are L2s, rollups with sequencers that are posting this kind of transactions to the main chain. The cool part is, like, the most easier way to understand would be, like, I always envision that Ethereum would eventually define a standard where all those headers or blocks that are, or data that is being pushed into the blobs, into the Ethereum beacon chain, will kind of get synchronized across the L2s. So I think, like in our case, assuming that, for example, you have four shards, one is beacon chain and 3 execution shards, and they all produce block one after another. Now, if the shards, for example, the shard header blocks would be pushed to meta chain, and the meta chain will notarize those headers, and the next block actually will be again fetched by the execution shards from what it will tell them, each of them, what's the height or the finality on each of the sources of the messages. Now, the cool part is you kind of build some sort of a trustless, invisible finality model synchronized across all the L2s. If you would apply the same Elrond or MultiversX model to Ethereum case, to the Ethereum case. The only problem is, I hoped that will be the end game, or at least if they drop sharding, that could work. With minimal changes. However, the problem is, the longer the wait and the more the chains go and post the data to another beacon chain, right? Then you cannot synchronize them anymore. Like I cannot know, assuming that, for example, you're a rollup, you're a rollup, I'm a rollup, and we're both posting the data to the beacon chain, and we're fetching the next block from Ethereum. We can both know, I can know from the block from Ethereum if your data was included without talking to you, right? So in this case, this is exactly how meta chain works for the for Elrond, for MultiversX model. But assuming that we're all going to talk to that specific beacon chain. Now, the next problem would be, and now this comes again to the sovereign chain, assuming that we're going to have 10,000 shards or 10,000 rollups in the space. Now, where would this data be processed, pushed to? So even if it comes only to a block header, to a minimum kind of information, you still have this kind of overhead of communication that you need to do and integrate and write this kind of minimum information into a notarization chain that will give us the synchronicity or the synchronity across execution in order to execute stuff directly from one to another, and not routing the data per se through the beacon chain. Now that's the reasoning. Like I've thought, okay, what if we are Ethereum, right? So assuming that we will get to the same problem, it's just a matter of time where each of the blockchains will just get to the same problems. Then what would happen? And in this case, for example, if you would apply the same principle as Ethereum, that means in order to my transaction to get forwarded to your chain, I need to compete economically speaking with all other L2s that my transaction will fit into that block space, very limited block space of one beacon chain. Now, for example, if the shards are being connected to the execution shards, and there's a proper messaging system through the execution shards will have tons of capacity to process tens of thousands of shards. So it's just the scale of things is just put it at the power of 10. Right, and then you'll get kind of the problems where everything will just kind of hit a limitation. I hope it's not too abstract and it just goes a bit to the design rationales.
Yeah, no, I think it makes sense. Is it then? I guess it's also a problem, especially since we have like sort of this L3 thing now as well, where someone posts then first to like the L2, and then I guess. Yeah, you have like another tree that is not synchronized with the beacon chain, and that might be a
100%. Exactly, that's the main problem. Like it would require that layer L2 to post the transaction or the state of that L2 to that receipt, or the state of that L3 to L2, and then from L2 to L1 in order to that message to get through. Like that won't work. And assuming that, as I said, that the L1 will still be the same. Like I think we do have a lot of data availability models and other stuff that kind of again fragments the state. If we assume that the model will be default as a sequencer, where only someone will keep the state, and in order to execute or trust anything, you'll need to kind of fetch that state. I think that kind of add some sort of challenges, like again some sort of challenges. How would you talk to each other? Then we'll fall back again to bridges. Or I think IBC is the good. I think I hope like thanks God IBC exists. They might save the entire messaging fragmentation across all those layers.
Right. Makes sense. Yeah. Okay. So we went like pretty deep here. I think hopefully we didn't like lose everyone along the way, but I think super interesting to hear this from like your experience, how you went through and how far everything has come. So maybe we can for the last few minutes switch a bit to like the broader MultiversX story. I guess you're not just building this tech. I mean, I guess you predominantly are like deep in that, but there's obviously like stuff being built on top of it. And I think what's interesting in your case is, that this is like a very integrated ecosystem with like many parts sort of handled in some way by your team, or like sort of the broader MultiversX ecosystem itself, versus like, some more fragmented thing that is like sort of Ethereum, I guess. So I guess maybe the question is, how do you think about this like ecosystem building and integrating things, or what's like the broader vision there? I think it seems like also sovereign chains are trying to bring a little bit more other people more in. So happy to hear how you're thinking about that and the future for like the sort of MultiversX ecosystem. Yeah,
definitely. So 100% agree with the part that we're trying to get even more ambitious people involved, but also the smart contract framework. It kind of proven, at least to some sort of the threshold, that it can work. So the dimension has pretty much all kind of primitives, from concentrated liquidity, stable swaps, all kind of AMM pools, liquid staking, multiple liquid staking protocols, and all that. So that's that. But now going even to the deeper level, if you want to persist and build a protocol that will be developed for a decade to come, you cannot train people only at the smart contract level and then assume that they will contribute to the protocol, right? So this is kind of a two-sided sword. I really hope that it will work. But maybe going back to your question, we kind of built many teams. Like now they're getting more like a spin-off their own space. But one of the products is Exportal, one of the spin-offs from MultiversX, where what were very interesting is our approach was, again, I think everybody remembers, build the platform and developers will follow, build pre-developers, user will follow. Like that's kind of a lie, but we heard too many cycles, and then we kind of we believed that naively enough, build the protocol and then waited for the users, right? And the users almost never came. And then while doing that, we could waited and waited to for some results, or said, okay, we're kind of hardcore engineers, let's try to do something about it. And that's how we actually start the next journey. And when with one hand we were kind of having this bottom-up approach with the protocol and sharding, scaling for masses. But then if you want to scale and reach mass adoption, then looking at the internet, there were like two moments. Like there was the fiber channel where you have distribution, like what the sharding does, and then we had the internet browser moment where you kind of have abstracted the entire complexity, when not only the geeks could work and start using internet, you kind of had the browser moment. And that's actually what we tried to do with the Exportal, where the portal would be your portal to everything. So it kind of abstracts the entire complexity. We built that kind of that product as well, which I think 1.5 million users in the first 12 or 24 months after launch. And then, that allowed us to build or at least experiment some very interesting stuff, like on-chain 2FA, right? So I can give you a very short, like where we come from, like we're the second unicorn of the country. And then there were a lot of people that put bets on us and believed in us and so forth. And we did not or we think that we did not went against other communities and so forth and built our own community base. But whenever people trust you and they put bets on you, they're taking a lot of risk. And what happened actually when you onboard 1 million users with zero experience in crypto, the hackers were in heaven. Like you could imagine how much social engineering against those users happened, and how many people kind of also lost money into all this kind of phishing attempts and all that kind of stuff. So we thought, what can be done such that the next bull run I can sleep good and know that even my parents are safe, right? So what we did actually, I said, okay, if we do like the external hold accounts, like EOA accounts approach, that would mean that every transaction would need to go to a VM execution, right? So it will need a smart contract to open, verify the signatures, and you basically, especially in the WASM environment, there's still a lot of work to do. Like it could get even better, and you don't want to add in a chain of, let's say where you call 10 smart contracts for liquidating AMM or whatever, just add another multi-sig on top or 10 multi-sigs on top, and with cryptographic primitives, it will just get worse. So we said, today's today, let's see what can be done. So we actually added a secondary field at the protocol level, which just checks a guardian, so-called guardian signature, which is basically the Exportal comes with a black box signature, a black box mnemonic, which you cannot read only through encrypted backup, such that it is foolproof. And then you basically, in that way, you register the application or the device at the protocol level to co-sign your transaction. So you basically cannot, even if I give you right now the mnemonic of one MultiversX account, there was a page like called Eagle Heist, where there were like 6 million people trying to watch or saw that post with a seed phrase published where they could not steal the money. Why? Because it required the same way even if you have my bank account login, you require the 2FA, the second signature, right? The second device that will authenticate you. And we kind of took the same principles as a bank account, as a staking account. You like assuming that I have a phone, here I have registered, and I have the second one where I am importing just the seed phrase and try to initiate this kind of transaction. And then the first thing, okay, I will notice I cannot move the funds because they're locked. Let me try to re-register a new, the same way you would call the bank and say, hey, I just want a new token. Fuck it, I lost that one, drop it. I need a new one. They say, okay, sure, I'll mail you one. Right, so they will first give you some sort of a buffer that it's not the gun held to your head while you're doing that call. It's kind of common sense. And then the process would be I try to register. I would send the transaction on chain that goes through. I'm allowed to do that, but the transaction has a bonding time of 20 days. Right. So in that case, the second device, which is already assuming that I still have access to my current device, it will have a notification similar to, for example, Facebook or Instagram or whatever. Is it you that you're trying to log in? Yes or no? If I say yes, basically it asks me, do you want to give the rights to this new device to sign, to move the balance or whatever, give the rights to sign the transaction? Yes or no? If I say no, then basically that account can just retry to re-register. But it cannot move any funds. The cool part, if I can say yes, then instantly it just goes and transfers the security. Now, those are like, on the one hand, just going back, on the one hand, you have this kind of super fast infrastructure, crazy, complex. And then on the other hand, you just go to foolproof versions of applications where I know that my parents are safe on the internet and they can do this kind of transaction. Maybe, and yeah, one of the very interesting parts is we also acquired, I think we're kind of the only L1s coming out from Europe, where we acquired and have an e-money license and a kind of neobank license to operate IBAN accounts, and have issued in partnership with MasterCard a debit card attached to IBAN accounts that now packing it with the protocol one, with the L1, packing it with a very cool user interface, you could basically just easily spend and use all this kind of super hardcore tech and cool stuff that goes decentralized and open border and so forth, but also on the same time just go outside and buy your beer, right? So what if? Our question was, what if we can do that? And actually it ended up that we actually were live with all this kind of crazy stuff.
Yeah, that's a really cool mechanism. Thanks for diving into that. I think so. Basically, like these 20 days, like if someone has a mnemonic, they can just try to register a new device, but you could still block it. But okay, if you lost any, you wait the 20 days, it'll automatically pass over just in case. Yeah, okay. So you do need to like interact a little bit with the account, at least frequently. If you lost a mnemonic, let's say.
Yeah. So it's not perfect, but the idea is, for example, assuming that my phone just got crashed, I don't have access to it and so forth. Then basically I still need to be able to recover this kind of the funds. And assuming that I do have access, I'm still getting notifications all the time, or I can just hear or listen to what the account does and so forth. Like, I don't think that the ideal case would be to lose access to the funds forever. Like,
yeah, no, exactly. There's like a sort of, okay, yeah, I think it's like you have to die one death somewhere a little bit. And I think this is like a nice trade-off that you're exploring or doing there. So yeah, that's quite impressive. I really like it. Cool. I mean, yeah, thanks so much. I think we went like super deep into everything. I hope people take away a lot about MultiversX and like understand how much cool tech you build and like what's still to come. Is there any final thing you want to say, or you want to like lead people towards, or want to make them aware of what's happening or how they can get involved? Then please, let's do it.
Yeah, definitely. So I do believe that there's a lot of stuff that is still to be built. As I said, like on the sovereign chains, there are the first I think couple of chains coming up, line up with EVM, bringing EVM composability and compatibility. Then there's should be we're looking and actively talking to several teams from Solana ecosystem to build a Solana VM, then move VM. That would be also a very cool part. And then hopefully to get one of the versions that will just wrap and have a unified execution environment across all those kind of crazy VMs. So what if I'm just openly putting it like that? Then while I think to believe that risk-taking is definitely, I think, very, very crazy idea that eventually kind of every ecosystem will have. And I mean here, big congrats to you, Felix. I know you had some very, very cool stuff recently announced. And hopefully we'll work together on that one as well down the road. There's a couple of stuff. I maybe also very, very interesting that I have not seen yet because of those licenses that we're also having with IBAN accounts. What if we're gonna build a chain or a chain framework that where the banks could just spin on their own infrastructure, right? So we're gonna explore with our own, put a framework together, and then work with the central bank to kind of let's see if that could be tokenized directly on chain, or what if I'm just throwing a bunch of stuff, assuming that legislation is being solved, the licenses are on the table, and we do have this kind of toolkit on the table. It's an open question to what can we build, like how far can we go, and that's, I think, just a matter of time until the way I'm thinking, just a matter of time until whatever you're thinking, I'm gonna think about it too. It's just a matter of time that until the ecosystem, if it's progressing good enough, it will get there.
Yeah, like you mentioned, like the consumer grade, like the core primitives consumer, and then the institutional enterprise. I like that framework as well. So I guess you are definitely involved in all the those areas. So
just let's note, it's funny enough, I just had an ecosystem call with the founders yesterday, and there's the Institute of Research and Engineering, I think, from the national government from Romania, that is being part, and they have an NFT marketplace running, and they're exploring with the sovereign chains. And the cool, even crazier part, there's a partnership between the government, the China government, and several European governments, where the China one is exploring to launch their own NFT marketplace as well for the national Olympics guys, and exploring that. Like how crazy it got, like from talking all this kind of crazy cryptographic protocols, then governments finally coming closer and exploring the technology
with NFTs.
Yeah,
maybe soon Chinese meme coin coming.
100%.
We'll see. All right. Yeah, thanks so much. I really enjoyed this, and thanks for being the first podcast in 7 years. I hope the listeners enjoy this episode, and get in touch with the Multiverse ecosystem. So
thanks a lot, Felix. Highly appreciate the time, and thanks a lot for the patient, guys. I know it might have been a bit tough with all that stuff, but sharding will come eventually to everybody.
Nice. Good final words.